Well, hello there, and welcome to yet another module. In this module, I'm going to be talking about the topic of diagnosis and feedback, so let's get right to it. Perhaps one of the first things to start with is just the various terms that are oftentimes used to describe what we mean by diagnosis. Terms like discovery, dialogue, analysis, interpretation, all of these are essentially just different terms for describing the essential question of what's going on here. This is a very important thing to know, because even if you know where you're wanting to go, say you're well in tune with the company's vision, right, you really can't begin to chart a map or steps toward going where you want to go unless you first know where you're at, right? Imagine trying to use your GPS and yet it can't locate where you're at. It's not going to be able to help you much in terms of getting to your destination. And so diagnosis is understanding essentially where you're at a given moment. We can think of it as an ongoing process of making sense of the data. And I want to emphasize this notion of making sense of the data. In the last chapter that you read, it really covered a number of ways in which you can go out and collect information. I thought that chapter was actually fairly straightforward, so I didn't feel a need to comment on it. But definitely, if there are any things there that you really didn't quite get, please feel free to comment or pose those questions in the bulletin board created for these mini lectures. But essentially those methods really concentrated on how to go forth and collect the data or collect the information. When we're talking about diagnosis, we're now talking about what do you now do with that information? How do you make sense of the information that you've collected? Unfortunately, data doesn't interpret itself. It's always subject to the interpretations of the people that are working with it. There are two very important ingredients to this diagnosis process. One is that it's very important that you see it as a process rather than as simply an event. You don't just do this once. You're always gathering information to examine where things are at. Sometimes things change in that case there. And so it's always important, especially if you're working on a project long term, which if you recall is one of the very identifying pieces of an organizational development perspective. So it's always important that you see it as a process rather than an event. Another important ingredient to this is that it must be a joint process. Diagnosis is not something that only the consultant does or only the client does, but it's something that they actually do together. And there's a very important reason why that needs to happen. The consultant helps the client typically with understanding the methodology and perhaps the statistical analyses that may have been used to analyze that data, but it's really the client that understands the culture and the reality of that workplace. And so the consultant bringing their knowledge about methodology and statistics to the client's knowledge about the culture of the organization, that's going to give you the best diagnosis in terms of what's going forth in that particular workplace. Okay? So now let's talk a little bit about the data analysis process. Once again, you've learned how to go forth and collect the information, but the next step is then to begin to make sense of that information, and we have to do that by analyzing that data. And there are two main approaches to analyzing the data that I want to describe for you, and that is the deductive approach to analyzing data and then the inductive approach to analyzing data. So we'll look at both of these separately. First, let's look at the deductive approach. Oftentimes this is called the top-down approach, usually also called the theoretical approach, because the idea here is that one starts with a theory and then you work yourself down from that theory. You can kind of think of it as sort of an if-then approach. If this theory is correct, then what might we observe when we try to look at that a little bit more concretely? And so generally in this approach, you're starting with a model. So if you think of some of the models that we covered last week, things like the Burton-Liquin model, the Naylor and Tushman model, the Weisbord models, for example. Of course, there are other models that we talked about. One could, in fact, begin with those models. And then, once again, if the Naylor and Tushman model is correct, for example, then what might we look at? And, of course, within each of these models, they highlight variables that then suggest these are the things that you ought to be looking at when you go forth and collect your information. So in a sense, what we're going to do with our data, if we started with a model like this, is that we're essentially going to be sorting the data into these pre-existing categories. Once again, each of these models have variables. That's what I mean by categories. And so it's a matter of taking the data and saying, okay, does this data fit in, Naylor and Tushman's idea of the formal organization or the informal organization, and the like. And so once again, deductive approaches, you begin with a theory or a model, and then you kind of walk your way down. This particular approach to analyzing data can kind of make things simpler because generally you probably begin with this model before you even went forth and tried to collect your information. And so your information, even the methods by which you collected information, were already somewhat organized by this model. So you already have some sense of where things tend to fit in the model. And so it kind of makes this process a little bit easier. But there are times when you might not be able to use a model. You're venturing into an area of the unknown. There don't tend to be many pre-existing models out there, and so you don't really have a model to work with. What are you going to do then? Well, you might consider then doing an inductive analysis. You can think of this as sort of the bottom-up approach, and this tends to be somewhat more typical of applied research. So, usually in the literature, people will make a distinction between theoretical research and applied research, and this is generally what they're talking about. They're talking about the difference between deductive analysis and inductive analysis. In the inductive analysis, you're actually starting with the data itself, and you then develop the categories from the data. And generally the categories are a result of the analyst's own labels in that case. So you might look at a few observations and then try to figure out what's really going on here. And once again, anytime you're venturing into the unknown, this is probably going to have to be the process that you start with. Some areas tend to be heavily dependent upon one of these methods more so than the other. So, for example, in disciplines like psychology or sociology, you're likely to see a more deductive approach. There's usually some theory, and then that theory gets walked down through these sort of if-then statements to something called a hypothesis, and then that's tested in that case. But if you think about the work of, say, ethnography or anthropology, in that case, they're more likely to start with a more inductive analysis. If they're exploring some unexplored culture or tribe or something like that, there isn't a pre-made theory from which to draw for. So they're probably going to first attempt to observe and then draw some conclusions based upon their observations. Now, of course, you might be wondering which of these particular approaches might be better, and I think you perhaps know by now that no one is better than the other. It depends upon a number of things. Probably depends upon what your questions are, but it also depends upon what you actually have the opportunity to do. And then, once again, depends upon, like I said, whether or not there are any pre-existing theories. If there's no pre-existing theories, then obviously deductive analysis is not really an option for you. So once again, which of these approaches is better really depends upon the question. What I might suggest is that when given the opportunity, one might actually attempt both. So, for example, what you might attempt to do is begin with an inductive analysis whereby you suspend any kind of a priori judgments, collect your data, walk it up, if you will, bottom up, come to some perhaps theoretical understanding phenomena, and then in an attempt to validate that theoretical model that you develop, walk it back down in that case there. So I do think that there's opportunity to do both, once again, provided that you have time and resources to do that. Okay? So let me move on and talk about a very important part of this, and that would be the statistical analysis. Not all analyses require the use of statistics. So, for example, if you're doing more of a qualitative kind of study, that doesn't always require the use of statistical methods, at least not the ones that are typically known. There are, in fact, established statistical packages even for dealing with qualitative data. But generally, statistics becomes absolutely necessary when you're dealing with more quantitative data. In other words, your data is something that can be counted, it is codified in numbers in some way, then you're definitely going to be able to need to apply some statistics. Statistics can be conducted with a number of established statistical tests and techniques. There are several computer software packages that are available out there. The two most popular would be something like SPSS and also SAS. Generally, those cost a little money, and so there are some packages that are less expensive. In fact, there are some that are available for free. In fact, if you folks have Excel on your computers, Excel can actually do quite a lot of statistical analyses. In many cases, can probably do all that you're going to need in that case there. So you might sort of explore that before you go out and attempt to buy something. But like I said, there are a lot of packages that are free. If you Google free statistical packages, you'll probably find them. But let's talk about some of the main categories. Statistics come in the two major flavors, if you will. We'll sort of describe them one at a time. The first one is what's called descriptive statistics. As the name would suggest, you use these statistics to describe the data that you have. So one of the major categories up under the descriptive statistics is something called central tendency. You can think of this as a more fancy way of saying the word average. People are familiar with that term, but perhaps what they're not familiar with is the fact that there are really three different ways in which we could calculate an average. The most typical way is something called a mean. I would presume that most of you have calculated a mean at this point in your lives, and so if you recall, the mean is simply nothing more than totaling all of the scores and dividing by the total number of scores that you have. But the mean is oftentimes limited. For example, it's limited anytime the distribution of your scores is not normal. Take something like income, for example, in our nation. Income is something that is not normally distributed. You have what we would call extreme outliers, people like Bill Gates and Warren Buffett, billionaires, tend to make so much more than a typical person, such that income is skewed. What happens in those cases is that the mean is something that is pulled in the direction of the skew. So it might shock you to discover, for example, that the mean income in our nation is around about $300-something thousand. This probably doesn't describe very many people you know. Definitely doesn't describe very many people I know. And so in that case, the mean is being distorted by this huge skew in the data, which is why anytime you have a non-normal distribution, it's preferable to use something called the median. So if you pay attention, at least to those statisticians that know what they're doing, they're more apt to present the median income than the mean income. And of course, the median income is significantly lower than $300,000 in that case there. So the median, generally, another way of referring to the median is that it's simply the 50th percentile. If you were to be able to lay out all 300 million incomes, assuming that all 300 million people in this in this country have incomes, and you were to pick the person standing smack dab in the center, you would in fact have the median income. So it's the 50th percentile, it's the person in the middle. The mode is simply the most frequent number. Right, so whatever number appears most frequently in a given distribution, that would be the mode. And depending upon the type of data that you have, one of these particular methods might be more preferable as well. And like I said, if you have more questions about that, that's something that you can feel free to talk with me about. Incidentally, one of the other classes that I do teach for the SPS program is the principles of data analysis. So I'm actually attempting to squash about 8 weeks worth of material into probably the next 15 minutes of this mini lecture. Okay, so definitely have much more that I could share with you. But let's move on and talk about variability. Not only would we like to know the average, but we're always concerned about, so to what degree do the scores hang together, or how different are they from each other? So we refer to the differences between the scores and the distribution as the variability. One way in which we might capture that is just by specifying the range. The numbers fall between, say, X and Y, if you will, 2 and 30, for example. Another way of estimating the amount of variability within our data is looking at something called the standard deviation. That's a fancy way of saying the average by which each score would differ from the mean. Generally, the mean is most preferable when our scores are normally distributed, and so we're generally interested in how much are the scores different from the mean. That actually tells us something about the mean. When your standard deviation is large, it's a really good indicator that your mean is lousy, right? Because that means that scores are differing from your mean quite a bit. On the other hand, when your standard deviation is small, that means that your mean is actually doing a very good job of representing all those scores. So going back to my income example, one of the ways in which we could tell that a mean income of $300,000 plus does not reflect most Americans, besides the fact that we don't seem to know anybody that tends to fit that bill, is the fact that the standard deviation of income is about maybe 400,000. Which is way too large given that mean. In fact, a standard deviation should never be larger than the mean as a given rule. So that right there would let us know that the mean is doing a lousy job of representing where the majority of people are in that given distribution. So we want to know the central tendency, we want to know the variability, but we would also perhaps want to know something about the relationships that exist between, say, two or more other variables. So, for example, we might be interested in knowing whether or not the level of job satisfaction in our workplace overlaps any with the amount of feedback that exists. A correlation is something that would represent the amount of overlap between those. So if those two variables can be said to be correlated, it might suggest that there's a link between them. Now, correlations can be either positive or negative. In the case of a positive correlation, we would say that as, let's say, your feedback becomes more positive, so does your level of job satisfaction become more positive. And incidentally, it'd be the same. As your feedback becomes negative, your job satisfaction goes down. Either direction would actually be an example of a positive correlation. A negative correlation, however, is when these variables move in the opposite direction. So if you can imagine for a moment that job satisfaction would go down as positive feedback goes up, or that job satisfaction would go up as positive feedback goes down. Now, this last scenario doesn't really make much sense, and so probably a better example of a negative correlation is imagine the correlation between the number of drinks that you've had and your driving performance. Right? As the more drinks that you have, your driving performance goes down. They're moving in an opposite direction. That would be evidence of a negative correlation, and vice versa. As the number of drinks that you had go down, your driving performance goes up. So this would be an example of a negative correlation. So whether we're talking about the central tendency or variability or relationships, right, these are just some examples of typical statistics that are offered to describe, if you will, our data. Okay? The second category of statistics is something that's called inferential statistics. That term inferential is just a synonym for the word hypothesis. And so, once again, as this name would suggest, you typically use these statistics to test a set of hypotheses. Our hypotheses can come into two main varieties. There are hypotheses about associations. And so we can use statistics, like the correlation. And so not only can the correlation be used to describe relationships that exist, but we can use it to potentially test hypotheses. So let's suppose for a moment that we believe that the more motivated people are, the higher their productivity would be. Well, we can use the correlation for that because, once again, it's going to look at the overlap between motivation and productivity in that case. We could use something called regression. Regression has the power of actually allowing us to make predictions. And not only with one predictor, but we could use multiple predictors. So maybe not only are we interested in, say, the impact that motivation has on productivity, but also maybe the impact that ability has. Maybe we really believe that it takes both motivation and ability in order to increase the productivity of people. So we could look at both motivation and ability as predictors and look at the impact that they have on productivity with something like regression analysis. So correlation and regression are considered the more popular statistics. There are others that are out there that one could use for association. But let's go ahead and move and talk about group differences. Oftentimes our hypotheses are really about comparing groups. So let's suppose that we wanted to compare, say, management with non-management on their levels of commitment to the workplace. Well, something we could use in that case is something called the t-test. The t-test is a statistic that allows you to look for the differences that exist between two groups. So once again, what we could do is we could get a commitment test, we could give it to management, we could give it to non-management, and then use the t-test to examine whether or not there is a significant difference between management and non-management, and also examine which of those two groups would be highest in their level of commitment. If we have more than two groups, then we would need to move to something called the analysis of variance. Very often it's abbreviated as ANOVA. And this, along with the concept of regression, is perhaps the most frequently used statistic. So if you were ever to pick up a journal, for example, you would likely see an ANOVA and or a regression. And in this case, analysis of variance can handle more than two groups. In fact, it can handle any number of groups. But let's just, for example, say we're going to look at, the relationship of shift work with fatigue, right? So we might take, first shift, second shift, and third shift, and we might measure in some way their fatigue and compare them. So with analysis of variance, we could compare 3 groups or 4 groups or 5 groups, right? Whatever would make sense to do. So it's a fairly powerful statistical technique. And once again, there are many other statistics that could be used to look for group differences, but I've tried to give you a sampling of the most popular of this category. So, wanted to give you some sense of the two main basic categories of statistics that one might want to become familiar with. And if you've not yet had the opportunity to have any training in statistics, it's something that you might want to consider, or definitely as an OD consultant, you definitely might want to partner up with a statistician who could perhaps help to analyze your data in this way. Even if you venture yourself to be a more qualitative researcher, it's very important to understand that even qualitative data can actually be analyzed using these statistics, because all qualitative data can be quantified in some way, shape, or form. Okay? So let me move then to talking about the giving feedback meeting. So at this point, you have analyzed your data. You've at least come to some statistical conclusions about what things might be significant or non-significant, if you will. But in this process, you're really attempting to engage the client in this joint diagnosis piece here. So you're giving feedback, but the idea is that there's going to be a joint diagnosis. So let's talk about some things that you'll want to be sure to do in this meeting. Number one, you want to remind the client of the contract and the purpose of the data gathering. It's always helpful to go back to why it is that you went down this road in the first place. It helps to keep people somewhat anchored to the main issue. Another thing that you want to do is you want to acknowledge and confirm the positive data. It almost seems to be kind of hokey these days because we've all learned that you should sandwich negative information with positive information. So even though the client may be somewhat suspicious that you're heading down that road, it's still nonetheless a good idea to do it. And not just because you're trying to sandwich the negative things, but it's very important. Positive data, the strengths, if you will, of an organization can oftentimes be leveraged to deal with the weaknesses of an organization. So you're not just kind of blowing air by doing this. You're really pointing to something that might, in fact, be a solution for the organization down the road. Okay? You want to be specific. You want to use examples. So rather than just simply saying that people don't like it here, right, you might cite some quotes. In that case, you want to be careful, however, you want to maintain the confidentiality or anonymity of the respondents to your survey or interview. So you definitely don't want to provide a quote that might give the game away. But you definitely want to make sure that you give some specific examples so people really kind of believe what you say. And of course, you want your examples to be things that sort of avoid blame. You want them to really just focus on the issues and the facts. You want to avoid projecting your own feelings. And there are a number of ways in which to think about how that might happen. Obviously, it might happen in terms of just interpreting the data, what the data means to you, in that case there. So you want to avoid sort of doing that. But also, even as you approach providing feedback, sometimes we might be attempting to anticipate, if you will, how people might react to quote-unquote good news or bad news. And so therefore you're liable to shy away, but you're kind of assuming that people are going to react in the same way that you would react. And they may, in fact, not react in that way. I've definitely had times where I came to deliver what I consider to be pretty bad news, and they were actually pretty happy to hear it because they had been suspicious of it all along, and it really confirmed that they weren't crazy, that they weren't odd, if you will. And so they were happy to hear that, and of course I obviously exhaled at that point. But had I been really tempted to try to shave off those edges, they really wouldn't have gotten what they actually hoped that they would get, in this case, validation of what they thought was going on. You want to confront the tough issues. Once again, you don't want to necessarily sugarcoat what you provide. You really want to make it very frank. You want to watch your language. You want to be careful with sort of the you are and why do you, that kind of stuff there. It's much better to present data more in terms of the respondents seem to suggest rather than more accusatory. You want to really, if you can, stay clear of evaluative language, weak, strong, indecisive, incompetent, right? Sort of a safer bet to really speak more in terms of effective, ineffective, working, not working, right? Things that are much more behavioral than evaluative in nature. You want to listen. You want to allow the client time to process. Keep in mind that this data is going to probably speak more to them than it is you. And so you definitely want to give them time to sort of process that. And you want to listen to what they're saying because they're perhaps giving you some insight into the meaning of that data. You want to be willing to change whatever interpretation that you've had to some extent. Right? So, according to what you think the client will accept, what they're likely to be somewhat resistant to, and you want to be open to the fact that the data or interpretation could be wrong. Right. So once again, it's a good reason why you don't want to a priori throw your interpretations in front of the client. It's better for you to listen first, because that actually might change the way that you even think about what it is that you're doing. And then finally, you want to come to an agreement on the meaning of the data and the next steps. Right? We don't just collect data for the sake of collecting data. We're collecting data because, once again, we're trying to figure out where we are. Generally, we have some vision already of where it is that we need to go. And so generally, the next step for the clients is going to be plotting out, if you will, some steps that it's going to take to get you from where you are to where it is that you're trying to go. So you definitely want to end this feedback meeting with speculating about some potential actions to take based upon that data. So definitely want to have a bias toward action. Okay? So here ends my mini lecture on the data analysis and feedback process. Once again, should you have any questions or comments, feel free to list those in the discussion board so that everyone can potentially hear my response to them. Okay, so until next week, take care and goodbye.